Um, okay. So the loop sections, so the loop section is going to be a lot of review for us, especially if you did the bootcamp prep materials. And like I said, today is going to be a lot of seeming review and prep, and then tomorrow going forward will be a lot more of your materials. So for loops, we'll talk about the two big ones are the while loop and the for loops, and then we'll talk about how break and continue work. And then lastly, we'll do a really quick kind of primer on debugging. Debugging is one of the things that the more you do, the better you get at it. And a lot of it comes down to practice, especially with understanding kind of where your code seems to be broken. So I'll do a quick section on that before we get into the workshops. Okay, so the first loop we'll talk about is the while loop. Okay, so a while loop has three basic parts. We need a while keyword. If you type while in any JavaScript text editor, you'll notice that it turns like either red or light blue, or basically a color that's not like the rest of your text. And that's because while in JavaScript is called a reserved word. Reserved words are things in JavaScript that already are predefined that have very specific meaning in the language. So that means you can't create a variable called let while equals 6, right? Because while means a while loop. Similarly with for or let or var or function, these words are all called reserved words because they have a specific purpose in mind and you can't use them for anything else. Okay, so while loop requires the while keyword. It requires a conditional expression that evaluates to a Boolean, which is everything basically in between these parentheses here. And then we need a code block. Whenever we say code block, it's kind of assumed that it also comes with the opening and the closing curly braces, because that's how you really kind of demarcate where a code block starts and ends. Okay, and so these three things are the basics of a while loop. And how while loop works is this code block will run over and over and over again as long as the conditional is true. So what that means is when JavaScript reaches this line of code, the first thing it will do is it will check the conditional. Is it true or is it false? If it's false, it will say, great, I'm going to skip to line 9. Okay. If it's true, it will say, let me execute this code block between line 6 and 8. After I execute the code block, let me check my conditional again. Is it true or false? If it's false, I'll skip to line 9. If it's true, let me execute line 6 through 8 again. And we'll do that over and over and over again until eventually that conditional becomes false. And we'll talk about like kind of what the implications for that are when we create a while loop. So this is a very common while loop, right? We have a variable up top on line 1 there called count. We set equal to 3 initially, and we say while count is greater than or equal to 1, we console log out count is, and we console log out the actual number. And then we do something here where we do count minus minus. This is the opposite of plus plus, which basically means let's set count to count equals count minus 1. So we subtract 1 from count. Okay, it's a shorthand. And so how this code is going to run is we're going to go to line 1. It's going to make a variable called count. We'll go to line 2. Then we get to line 3. And on line 3, the first thing we do is we check the conditional, right? What's the conditional? The conditional is count greater than or equal to 1. Is that true or false? Well, what's the value of count at that point? 3. Is 3 bigger than 1? Yes. So that means we execute lines 3 through 6, right? How do we execute it? The first thing we do is we console log out count is, and we do count is 3. Then we subtract 1 from count. So then now we go back to line 3 now, and we look at our conditional again. What's the value of count now? 2, right? And is 2 bigger than or equal to 1? Yes, it is. So then we execute lines 3 through 6 again. Line 4 says, let's print out count as 2. Then let's print out, let's subtract 1 from count. So then we go back one more time, and we say, okay, what's the value of count now? 1. Was that a 1 or a groan collectively from the class? Like, all right, so count is 1. Is 1 greater or equal to 1? Yes, it is. Let's do lines 3 through 6 one more time. We do count is 1, and then we subtract 1 from count. And now we don't finish yet, right? Because as far as the while loop is concerned, I'm still in my keep going mode, right? What's the next step in my while loop? Okay, let's go back to line 3 now. What's count now? Count is 0, right? And then the line 3 becomes, is 0 greater or equal to 1? And the answer is no, it's not. It's false. And only at that point do we stop, right? And in this case, stop means we say, great, this while loop, so lines 3 through 6 is complete. We now move to line 7 and onwards, right? So the one thing that people tend to forget is that the while loop and the for loop really is going to run one more time than you think it does to actually verify that it's going to be false before it stops, right? As humans, we're like, oh, 3, 2, 1, then we stop, makes sense. To the computer, it's actually 3, 2, 1, 0. 0 is false, and then we stop. This is pretty familiar, right, to everyone? While loops? Great. Similarly, if we have a while loop like this, where the first thing we write is, while false, right? So basically, we're just going to say this conditional is always going to be false. Well, this code's going to run. It's going to run. The first time it's going to run is, hey, what's my conditional? It's false. Is that true or false? It's false. So we're done, right? So we skip lines 1 through 3, and we move on to line 4. Nothing gets printed out because, once again, this while loop is running, but because this conditional evaluates to false on the first try, nothing inside the code block ever runs. So with every while loop, you're not guaranteed always a success run, if you will, but you're guaranteed to always reach a fail run, right? Because it needs to know when to stop. And if there is no fail run, which we'll see in the following slide, you get something really bad, which is something like that. In this case, modern computers are pretty good at handling this kind of stuff. Usually past a certain point, which is very kind of fast for humans, maybe like half a second, it'll say, hey, I think this is a human error. I don't think you want us to run infinite times, right? Because right now, this conditional is going to run infinite times, right? So say, conditional true, yes, run it. Conditional true, yes, run it. And that will just go on nonstop. Most computers now will cut you off at a certain reasonable rate. But that's the reason why we always need at least one fail run in the while loop. Otherwise, it will never stop. Similarly, here's another example. This looks almost identical to our first while loop example. The only difference is we took out that extra line that says, let's subtract 1 from count, right? So we have count is equal to 3, but we never change count ever again. And so upon our initial check, is 3 bigger than or equal to 1? The answer is yeah. Well, if that's true the first time, and we never change count, and we never change 1, then that's never not going to be true, right? And so this is almost identical to the previous example where we had while true infinite times. And so that's why this is running infinite times. And so this kind of points out the bigger idea of a while loop, which is every time the while loop runs, we need to make sure that the while loop is getting closer and closer to a failure state. That failure state doesn't have to be known, but we need to just kind of be getting closer to it. So what's the example of a time in which we don't know when it's going to fail, but we assume it's going to be close? Let's say I want to keep rolling a die until I get a 6, right? I can't tell you when it's going to happen, but if I roll it 1,000 times, I expect it at some point to fail, right? Unless, of course, the program is broken or something. So even if it's not like definite, like inherently in the while loop, the idea is we're always getting closer and closer to at least one failure run. The success run is not necessary always, but the failure run is always necessary. Any questions on while loops? Okay, cool. Yeah, I kind of go through while loops pretty fast, and the reason why is because you generally tend to not see them as much in the wild, and it's just because there is this kind of risk of having it run infinite times, and people are just a little bit wary of it. When you write one small code snippet and it fails, you're like, oh, great, let me kill it and restart it. When this is part of a bigger application, right, and it runs sometimes deeply embedded and you don't see it, it becomes a lot more dangerous. So if, for example, you had a loop that was sending out emails to people, well, if you had a while loop, then it would just send infinite emails to people, right? It really spam until someone like either your computer shuts it off or your email provider shuts you off at some point. But you can see how like while loops can be pretty dangerous if not written correctly. So that's the main reason why for the majority of this class we'll see the for loop a lot more commonly. The for loop also has 3 elements. We have the for keyword, right? So for is also a reserved keyword. You cannot have a variable called for in JavaScript. It has 3 optional expressions. So whereas with the while loop we have 1 conditional, now in this for loop we have 3 things. We'll talk about which one of them are, and then we go back to our block of code, right? Which is marked by the open curly brace and the closed curly brace. When you talk about it, either with me or with your partner, be sure to be very distinct when you say parentheses, curly brace, and brackets, because those 3 are very different things in JavaScript, and they mean very different things. So I know people tend to use those terms sometimes interchangeably, but they're not, right? Like when you say a bracket, it means a very specific thing in JavaScript versus a curly brace or parentheses. Okay, cool. And so The for keyword in the block of code I think are pretty straightforward. The inside this option, these expressions, they're actually very similar to the while loop, right? There may be three of them, but they basically do the same thing that a for loop does. The way a for loop runs is there's three parts in the optional expressions, right? The first part is called the initialization. The second part is the condition or the conditional. And this middle part is actually almost identical to what we saw in the while loop, right? Basically, something in the middle that evaluates to is true or is false. And then something we have called like the final expression. So what does this mean? Well, initialization in programming usually is something that you create that only runs once, right? Because you don't want to initialize something over and over and over again. It wouldn't be an initialization, right? So in the for loop, initialization basically means let's create like a tracker, let's create like a marker or something we'll do to create only once, and that's going to be what we use over the course of this loop. The condition then becomes something that we check to make sure, hey, should we run or not? Should we run or not, right? Similar to a while loop. Is this going to be true or is it going to be false? If it's true, I'll run this code block. If it's false, it means I'm done and I stop. And then this last thing, this final expression, this is basically, in the while loop example, this is our like count minus minus, right? This is what modifies that thing that hopefully is going to push us closer and closer to a failure state. Because like a while loop, a for loop also has to be able to end at some point. So let's see how the for loop works. Oh, well. So here on between lines 9 through 11, we have this for loop. Our initialization is let I equals 1, right? And we run that I equals 1 only one single time. So throughout the course of this for loop, we only have one I variable, and it's going to be set to 1 initially. Then we do our check if I is less than or equal to 3, right? So this should look almost identical to the while loop we had earlier, where count is less than or equal to 3. Same idea. And then we have this I++, right, or we add 1 to I. And our code block, this console logs out what I is at that moment. So when this for loop runs, the first thing it'll do is it'll create a variable called I equals 1. The next thing it'll do is it'll check, is I less than or equal to 3? In this case, 1 is 3, so yes, 1 is less than or equal to 3. That means we go from here to the code block, right? We don't do this part just yet. We go from the conditional, which says run the code block. We run the code block, so we log out I is 1. After this code block finishes, then we run this last part here, right? Which is to modify the variable, the counter that we've created. In this case, how does it modify the counter? Basically says, hey, let's add 1 to I, okay? And that's considered one like loop, right? So we go from initialization to conditional to code block to I forgot what was like optional expression at the very end. Okay, so that's one run. On the next run, do we do the initialization again? It's not a trick question. It's only 2 possible answers.
No.
Osiris, do I do the initialization again?
No.
Why?
You already did.
Right. For every for loop, I only initialize a counter once, right? In fact, if I initialize a counter every single time, this is going to run infinite times, right? So the second run is I skip this initialization. I jump straight to the conditional. On the second instance of this, what's I now?
2.
I is 2, right? Because in the previous run, I ended that particular iteration by adding 1 to I. So now I is 2. We say is 2 is less than or equal to 3. Yes, it is. Great. Let's log it out. I is 2. Then we add 1 to 2, and now we've wrapped up the second iteration. Let's go to the third iteration. Third iteration now. What's I equal to? I is 3 now, right? Because the last thing I did in the second iteration was add 1 to I. So now I is 3. Is 3 less than or equal to 3? Yes, it is. Great. Let's run our code block. Let's log it out. I is 3. Then we run one more. We say, let's add 1 to 3. And guess what? The for loop's not done yet, right? Because as far as the for loop's concerned is, I'm still in my perpetually running mode because you never told me to stop, right? Now, let's do this. So on the fourth one, what's I now? I is 4, right? And now we say, is 4 less than or equal to 3? And the answer is no. And so only at that point does a for loop say, hey, I've reached my conditional false state, right? I've reached a condition in which like this light now basically turns red and says, don't go anymore. And then I say, okay, great, this for loop is done, which means we're done with lines 9 through 11. Let's move on to line 12 so we can execute the rest of the code range. Okay, so with both for loops and while loops, right, this conditional stays constant, except in the while loop, we sometimes initialize this outside of the while loop, and this, we do it in the body of the while loop. Here in the for loop, we're just a lot more explicit about it. We say, hey, we're going to start here before anything runs. We're going to check this, and after every run, we're going to do this to that counter, that iterator, whatever you want to call it. And the reason why we call it I in most cases is because it stands for either index or iterator or however you want to call it. But the idea is we kind of lay out in the very beginning, like this is where we start, this is what we check, and this is what we do to eventually get to a closer and closer to a stopping point. So with a while loop and a for loop, a lot of times you can rewrite the same thing in both ways, right? You can rewrite a for loop with a while loop, or vice versa. People tend to use for loops a little bit more, just because, as you can tell, it's a little bit more explicit about when you start, when you stop, and it runs a less likelihood of running these infinite loops, although it's definitely still possible. So, any questions on for loops? Yeah, Josh.
Can you use the I in multiple for loops in one application?
Can I use the I in multiple for loops?
Or do you have to change the letter?
The answer is, well, so are these loops embedded or not, or are they just sequential?
I guess both.
Well, so if there's so let me show you what I mean by that, right? Oh, actually, this is a good segue. So there's a site called Repo that I tend to really like a lot. What it does is this repl.it. I'll actually share it with y'all here. Okay, great. Okay. So for Repo, what it does is basically it's an online tool for you to like write the language of your choice. For us, it's JavaScript, and so it's a really quick and dirty way for you to just like type JavaScript and have it run really quickly on a one-off basis. So the reason why I ask is because let's say I have something like, so let me copy this code over, right? If I have something like this, I can use I if the for loops are sequential. And the reason why is because whenever I do this variable I, because of the word let, we'll talk about what let does more specifically. Basically, this I only exists between lines 1 through 3. By the time I reach line 4, this I no longer exists. So I can create a new I each time, because each time there's no previous version of I that could possibly like confuse the computer, right? So this is totally valid. However, if I wanted to do something like this, if I want to say, hey, in this for loop, and we'll do this later today, let's do this. This is probably less kosher, and this will cause some issues for you, because guess what? On line 4, when we say like I equals whatever, there's already a version of I out there, right? And so that could cause some confusion. You could probably find a way around it, but the general rule of thumb is you don't want to use a variable that already exists unless your intent is to use that variable, right? So this is less recommended. But if you're going to be copy and pasting them sequentially, kind of one after the other, it's totally fine. Yeah.
Is it just better practice to use a different letter though?
Yeah,
Even if it is sequential.
It's better practice to use a different letter. If you have multiple for loops going, it's actually better practice to even name it something other than I.
Yeah.
Just because if you're iterating over 3 different arrays, like you can call them like array 1 iterator or array 2 iterator. You'll see a few examples when we do the arrays workshops of kind of when you talk about nested arrays, how like using even like I, J, K, like it gets really confusing after a while because you don't really intuitively know what I, J, K are, right? Or how to keep track of them. So we'll see a few more examples of that later on. Okay, cool. Go back here. So that's a for loop. If you notice the way I talk about a for loop, right, is we have a starting point, we have a check, and then we have a do something for a counter, right? And that's agnostic of direction. So in this case, we're saying we can also say, hey, let's make our first number like really big, like 5, and then we'll check to see if I is greater than 1, and then we'll subtract 1, right? So this is kind of like our while loop, right? Like let's start with a big number and work our way down, as opposed to start away from a small number and work our way up. For loops don't care, right? Because for loops just does let's initialize the value, let's do a check, and then let's change that value, let's do a check, let's change that value over and over again. So it doesn't matter if you're going small, going big, going every other, increasing by 1,000, decreasing by 1,000,000, like it just doesn't matter, right? It just checks, changes, checks, changes, checks, changes. And if for every check that's a positive, it will run the code block that you listed out for it. So it's very, very flexible. And one of the problems, either today or on Monday. It's actually better for you to iterate through a particular thing like in the opposite direction of what you think it should be going. And so it'll be a way for you to practice this concept, right? But just know that the for loops can do this. Like there's nothing about a for loop that inherently says you have to go from left to right, smallest to biggest, whatever, right? It's completely independent of direction or size. And then, yeah, same idea here. We don't have to go up by 1 every time. In this case, we're going up by 100. And once again, right, it doesn't violate our check, change, check, change framework. And so we can go up or go down by whatever number that we want. Okay, cool. So then let's talk about like another use case of for loops, which is to iterate through, in this case, a string, right? Strings are something that hopefully everyone is somewhat familiar with, and I think in the workshop prep we do have you iterate through a string, right, where you kind of understand a string is a collection of individual letters, and the way that you access any particular letter in the string is to use this bracket notation. We'll talk more about the bracket notation and kind of what are some ways to use it when we talk more about arrays. But for now, just know that, or at least I hope you're comfortable with this idea that like if I have a string in this case called letters, if I do letters.length, that's going to give me a numerical value. That's going to tell me how long this string is. And then if I want to access any individual letter in this string, then all I got to do is say letters, use the square brackets. I pass in a number, which is a position or an index, and it will give back to me the letter at that position. And with all indexes, we always start at 0, and we work our way, 1 by 1, which means the last highest index is always going to be the length of the string minus 1, right? So because if my string has 6 letters, my index goes from 0 through 5, inclusive on both sides. Okay, so here we're using a for loop. We're saying, hey, let's start with I equals 0. Okay, nothing fancy there. We're saying while I is less than letters.length. What was letters? Letters is a string. What's the length of it? In this case, it's 7. There's 7 letters in here. So letters.length is going to be 7. And after every run, we increment this I variable by 1, right? And so when we run this, the first time we do this, we say I equals 0. So is 0 less than 7? Answer is yes. Let's run our code block. Current letter is going to be whatever character is at the 0th index of the string. What's at the 0th index of the string? The letter A, because it's the first letter, right? The 0th index is the first element or first character. So we print out A, and then we do our increment of saying, hey, let's add 1 to our I. So that's our first run. By the time our second run comes around, we skip the initialization and we say, what's I now? What's the value of I for our second run here? It's 1, right? Because we started at 0, and the last thing we did during the first one was add 1 to it. So 0 plus 1 is 1. So now we're at 1 is less than letters.length is still 7. Is 1 less than 7? Yes, it is. Great, let's do this again. Current letter now is going to be whatever character is at the first index or the second position of this letter string, which is B. So then we print out B. And we just keep doing this over and over and over and over again until at what point do we stop?
When it gets to 7.
Right. When I becomes 7, we stop because letters.length is going to be 7, right? And so 6 is going to be less than 7, so we're going to keep going. 7 is not less than 7, and so at that point we stop. So essentially, we're going to run this loop how many times?
7. 7.
Yeah, exactly.
Yeah.
Good. Right, so we're going to run it 7 times because even though we start at 0, by the end of the first run, we're at 1. In the second run, we're at 2. And so by the end of the 7th run, we're at 7. And so this is a way for us to essentially, using numbers that increment and using that as the index, we're able to get access to every single letter in this string. Cool?
I have a question.
Yep.
Just
Please.
to be clear that I'm getting the language right, you would say that the loop itself runs 7 times, but it's checking the condition 8 Because when it checks the condition the last time, when I equals 7, it does not run the loop.
Yep, exactly. Yep. Yeah. And like I say like the loop stops there as like 8 times. I think in my mind it kind of makes sense. It's not like hard and fast. Like different people could define it, but now like some of them might say, well, the initialization is like the first step of the loop, so that could be its own step, whatever. But just conceptually speaking, like that's the workflow. So whenever you want to think about it, like that's the way to think about it. Any other questions before we move on to break and continue? My sincere hope is that most of this is review based on the pre-work that you've done. Yeah. Any other questions on for loops or while loops? There's never any questions for this workshop, like for this lesson, like ever. And then the workshop, people just like get very flummoxed very quickly. It's kind of interesting to watch.
Well, what do people get from it?
Well, like for example, we use a for loop. Like I think a lot of folks like even though as I'm explaining to you right now in this example, like people are like they're very clear what I is as an index. In the workshops, they're like, oh, is I like the element here? Is it a number? Is it the actual character? Or is it something kind of different, right? And so these are the things where like when I tell you like, oh, I is a number, you're like, that makes sense. When you write it yourself, it becomes less clear, like kind of what I is. So, you know, I can't prevent you from kind of hitting against these roadblocks when you do your own code. So kind of like you'll have access to these slides, so feel free to refer back to them. But when we talk about debugging, we'll also talk about some ways to just kind of make sure that you, like your assumptions are correct. Because a lot of times I think people read or write code, they tend to like make assumptions that they operate on, but they never test to see if they're actually correct or not. And so the entire time they're like, well, I is clearly this letter. And by the very end of it, they're like, oh crap, like I was a number all along. So anyway, we'll get there.
Question on that?
Yeah.
So the I in arbitrary, could it be Q?
Yeah, I mean, you're creating let I equals 0. You're basically creating a variable. So you can call this whatever you want, as long as you use that variable consistently for the rest of your code.
But it has to be a letter.
It doesn't have to be a number either, right? Because it can be let I equal, this could be a string, and as long as you're conditional with something that can measure a string properly, it can be anything. There. Josh.
When the condition is false, will a for loop execute the code block, or like a while loop will it skip it?
By definition, like that's when the for loop done, so it would not run the code block.
Okay.
That's like the thing to tell it not to run the code block.
But if I is 7,
Yep.
that means 7 is not less than 7, so shouldn't it not run the letter G?
Well, so what index is G at?
7.
Nope. Where do indexes start?
Oh, right. Okay.
Yep.
That's that. Thank you.
Exactly. Yep. Yeah. I remember when I was first starting off, at so many points I was like, "Oh, JavaScript's wrong," like, and I'm right. And then as you think about it more and more, like, just trust me on this one. Like for the first, like most of the workshops that you're doing, like previous cohorts have done before you. So we've done a pretty good job of capturing most of the bugs from it. So if you have any questions, like feel free to raise your hands and ask. The other thing is feel free to Google like outside resources, because any question or problem you guys come across of like, hey, I want to do this and I can't, most likely there will be like a lot of people who already posted a very similar question on Stack Overflow or somewhere on the internet. And so learning how to kind of read through other people's like evaluation of certain problems is a good debugging tool that we'll talk about later on as well. Okay, so the two things that you may not have seen in the pre-work relating to loops are the continue and the beginning to blank on the next one. Anywho, the continue is the first one. Continue basically says, hey, let's say I have a loop that's going to run like 8 times, right? Continue says, at some point, if on the 3rd iteration I have a continue, it basically says, hey, we don't need to run the rest of the 3rd iteration, but still, like, proceed normally for the 4th, 5th, 6th, 7th, and 8th iteration, right? So what the continue keyword does is basically says, let's stop this particular iteration, but let's go to the next iteration still. And so let's see how that looks here in the code example, right? Here I have a for loop, right? I start I equals 1 while I is less than or equal to 5, and I add 1 to I every time. In my code block, I have 2 things. One is an if statement that says, if I is 3, continue. Otherwise, if I don't continue, then I console log out I is blank, right? So when I go through this code piece by piece, the first iteration will say I is 1, 1 is less than 5, is I equal to 3, no, 1 is not equal to 3, so I skip lines 3 through 5, I console log out I is 1. Then I add 1 to I, and now in the second run, I is 2. I do the same exact thing, 2 is not 3, so I get to line 7, I say I is 2. I then, at the end of the second run, I add 1 to I now. So I is 3, right? So is 3 less than equal to 5? Yes, it is. Let's go inside this code. Is 3 equal to 3? The answer is yes. So then I actually go into this for loop, we go into this if statement, and then we hit line 4. And at that point, we can continue. And what continue says is, hey, for the rest of this iteration, don't bother running. Pretend like this iteration ends right, this code block ends right here, but do proceed on normally to the next iteration of the loop. Well, what is the next iteration, or to the next step of the loop? What does the next step look like? The next step says, well, let's add 1 to I still, right? So by the end of the third iteration, we never print out I is 3, but we do add 1 to I. So next run, I is now 4, right? So then when we do our conditional check of is 4 less than or equal to 5, the answer is yes, it is. Is 4 equal to 3? No, it's not. We skip lines 3 through 5, and we console log out I is 4, I is 5, and eventually we stop at I equals 6, right? So in this case, like, what the continue keyword does is basically tells you, don't run any more code for the rest of this iteration, but still proceed on to the next iteration. Pretty clear, everyone? Okay. Well, if it's not clear, then hopefully like it will help when we and this is basically saying continue also works in the same way for while loops. Basically it says stop running the rest of this code for this while loop and move on to the next iteration, right? So for a while loop, it's like move on to the next check to see if something is true or not. So if continue is a little bit confusing, it might be helpful to kind of contrast it with this break keyword. The break keyword basically says, hey, like if I hit break, it means let's stop the rest of this iteration like continue did, but let's also like not run any future iterations, which basically says like let's end this entire loop right here, right? So whereas continue says let's end this iteration of this loop, but continue on for all the future iterations. Break says let's end this iteration for this loop, and let's end all future iterations as well, right? So break is somewhat, you can think of it as more drastic or more severe in that it not only kills that iteration, it kills all future iterations as well. So here, if I'm trying to add extra plus signs to my grade, what I'm saying is, hey, once my grade reaches like A++, let's break, which means let's exit this while loop entirely. And in fact, if you notice, this while true here basically tells me that if I don't have a break somewhere in my while loop, that loop's going to run infinite times, right? But break is something that tells us, hey, like when you hit the break, stop running all future iterations of this while loop. And so after we hit break on line 8 there, once my grade equals A++, then we're done with this entire while loop. Also make sense? Yeah? No? Maybe? Kind of? Okay. Yep, and it also works for loops as well. Same idea. We stop this loop at that moment, and then we stop that iteration at that moment, and then we don't run any future iterations either. Cool. Right, so whereas before, in the last example, we skipped I equals 3, right? Because we had to continue, it skips I equals 3. Here, instead of I equals 3, we have I equals 7, but instead of continue, we have a break, which basically says, hey, like, after we run I equals 7, like, we're not running 6, 5, 4, 3, 2, 1, 0, like, we're done, right? So no future iterations are going to run here. Okay, any questions on breaks?
How often is it used?
What's up?
How often is it used?
Often as you needed to. And I don't mean it to be facetious. It's like, how often is the letter V used? Like maybe not that often, but if you need it, like use it, right? I mean, these are just tools. With breaks and continues, there's probably ways you can get around never using it if you really hate them, but they're tools, right? So use them as often as you feel like they're needed. Okay, cool. I'll just make one last side comment to another distinction that I know people tend to get a little bit tripped up on. Console log versus returns. Okay, so console log you can think about as console logs are things that help the human see kind of what's going on like in the computer. Most of the time when we use console logs, it doesn't affect how the computer runs the software at all, right? Like so think of console logs as almost like a human-only process whose only job it is to make it easier for humans to kind of see what's going on with the computer. The computer doesn't care about console logs at all. Returns, on the other hand, is something that means something very specific in JavaScript. So the analogy that I gave in the last cohort, right, was think of return as like actually handing something in. Like let's say you were in class and your teacher, had a test or a paper or an assignment, right? A console log is you giving her a verbal update, like, oh hey, I'm working really really hard on your paper, or I'm really studying hard for your test, right? The return is when you actually want to hand in that paper or handing that test, right? In the sense of like the teacher is like it's like a nice to know, like hey, you're working really hard, but it doesn't mean anything, right? Because it's just like look at me, right? But with a return, it's like here's the actual thing. The other thing that I want people to be aware of with returns is not only does a return kind of give back something, whereas a console log only prints it out, a return also ends the function at that point. So you know how like with the break keyword, I say, hey, in this loop, as soon as you hit the break word, the entire loop basically just finishes. Well, when you use return, it basically means, hey, that when we hit the return, that entire function finishes, right? Like nothing else after that's going to run. And so that's why normally in the vast majority of cases, when you look at functions, you'll know that you'll see that the return is usually the last line in a function. And the reason why is pretty clear, right? If I have anything else after that return, it's never going to run. So it should be like the last thing, right? Like once I hit my return, it says do this, and I'm done. Okay. So when you work on your code, just be very careful that console log is meant to print something out that makes it easy for you to read. A return is actually a computer's way of kind of handing in something to whoever asks for it, right? So if you're calling a function, if you're executing a piece of code, and you expect to get something back from it, like that's when you want to use a return. And once you do use the return keyword, that function is now done, right? Like if you're working on your final, and the teacher asks you like, oh hey, like how's it coming? You say here's my final paper. Like after you hand it in, like nothing else you do really matters, right? Like that's the end of it. So it's probably a bit more nuanced thing that as you work through more and more of the workshops, you'll get a better feel for. But I'll just kind of caveat that now, and I don't know, you might still need that reminder when you do the workshops. Cool. Okay, so next part, debugging. So if I could make a pie chart of kind of if my boss was like, hey David, can you build this new feature out for me, right? If I could do like a pie chart of how my time is spent, I would probably say like 40 to 50% of the time is reading code that already exists in the code base and to figure out like where does this belong. 25% of the time is probably spent like writing the code for this new feature, and then the other 25% of the time is probably spent testing it and making sure it works, and just doing other things to make sure that like it actually works the way I want it to, right? To get it to kind of roll out. And so the reason why I say that is because, or rather, the last 25% is making sure that works, which includes both like making sure the code is operational and it also does what I want it to do, right? And the reason why I say that is just because very little part of programming is actually spent like writing brand new code, right? In most cases, what you're doing is you're trying to figure out where can I insert my code so that it won't break anything else that already kind of exists. And so you'll spend a lot more time reading code and debugging and fixing code than you do writing new code, and that's perfectly normal. Every developer does it that way. So for today, what we'll do is spend a few slides looking at kind of quick and dirty ways for you to at least try to figure out when your code's not working correctly, like how can I figure out where the source of the problem is or what the problem is or are. Okay, so starting from here on out, for all of your workshop problems, when you run them, they will fail now. They won't all succeed for you organically. They will all fail, and your job is to try to get them to succeed, right? When everything's green, it means you're done with that problem. When you look at this, when you look at these failures, know a few things, right? One is if you scroll down, like on the workshop problems, you'll see all the tests being run on the bottom, right? So when somebody says, hey, this test failed, you can actually go down in the actual code and see how they're running the test, right? It's not just arbitrary. Like they will actually call the function and say, I expect this function when I call it with this to give me this answer, and it's not, right? So when you look at these failures, like these failures come back in the order in which the tests are being run. So if you have like, so in this case, it's like, I have green x, 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 it means the first test, the first thing I ran is passing, the second, third, and fourth thing are all failing, okay? The second thing is, it will actually usually give back to you the last error that it reached, or rather the error that's causing it to fail. Computers are not very smart at kind of predicting errors. More often than not, what computers are going to do is they're going to try to do the things that you ask it to do until it can't do it anymore, right? So in this case, when I see the error called reference error, what reference error means is a very common error is, hey, you're trying to use a variable that either you haven't created yet or you don't have access to. So it's almost like it doesn't exist, right? And so in this case, like the reason why I say a computer will try to do that is a computer will try to use a sum variable. It will look it up, it won't find it, and then it'll say, hey, David, here's the reference error. You're using a variable called sum that does not exist. Okay. In the test specs, whenever you fail a test, it will give you back the last error that you got, and that message may or may not be useful, right? Sometimes what happens is you fail something fails like up here, but the rest of the code will still run until it breaks much further downstream. And so at that point, it's up to you to kind of figure out how you got there, and that's why everything else like beneath is also like a pretty nice way for you to kind of figure out how you got there too, right? So the line right beneath the error is the last thing that ran before the error got triggered. And the line beneath that is what ran before that line ran successfully, right? And so what you have is you kind of have this timeline path of kind of how you got to this error, going from the first step, which is the very bottom, all the way up top. So as you go up, it gets more and more recent until you reach your latest step, which is going to be the failure, right? And so the way to read this code is this first part URL, you can kind of ignore it. You'll probably just look for your file name, and then it'll give you two numbers separated by colons. The first number is going to be the line number. The second number is going to be your character number. Usually the line is kind of what matters. The character matters a lot less. So in this case, it will say, oh, okay, we tried running onlyOz.spec line 8, which led us to run onlyoz.js file line 11. And when we try to run line 11 and character 7, we hit this sum variable that does not exist. So that probably tells me, okay, let me start looking there, right? Like, am I using a sum there? Probably am. Why does it not exist? Did I not create it, or did I create it somewhere else where I now don't have access to it anymore? Okay, so as you do more and more workshop problems, like you'll get more comfortable reading these error messages. And even when I come across, right, like if you say, hey, Dave, I'm having trouble with this particular workshop problem, I'll say, great, like what's the error? Like where are you failing at? And then you can go back and kind of recreate the error yourself. Like that's phenomenal, right? Like that's kind of how you start developing a framework for not only solving problems, but also being able to work back and trying to figure out what the root problem is. So this just says the line thing I told you about. Google stuff, you don't know. Hopefully at this point everyone knows that already, but almost any problem you come across now, like someone else before you has probably come across it. A lot of people before you have probably come across it. Okay, failing tests. So in the previous example, what we saw was a reference error, right? As I'm saying, this code cannot run because you tried using a variable that does not exist, right? It's like a non-starter. However, there's a second class of failure, which is saying, hey, your code runs, it just doesn't give me the answer that I thought it would give me, right? Like if I was to write a function that says, hey, let's add two numbers together, one error is saying, hey, this code doesn't run. You're trying to add a number that doesn't exist. The second error is saying, hey, I got a number back, but it's not what I thought it would be. Right? I tried adding 5 and 10, I got back 13. What's going on? Right? The code's not broken. It's running. It's just not giving me what I wanted to. And so that's when, within the context of the workshops, you'll see this expected blank to equal blank. Usually, this first thing is kind of what you gave back or what your code gave back as the answer, and the second thing is what it was expecting to get. Right? So in this case, the answer should have been 25, but our code gave it back 55. And so that also tells you, hey, your code runs, but there's probably some inherent flaw in your logic. Right? So before you dive into fixing any of your code, always be sure that you're pretty clear on kind of what the problem is that you're fixing in the first place. Yep. And then this basically just tells you like when you're in the code pen, as you scroll down on the big code block, you'll see all the tests being run at the bottom. So if you're ever unsure as to why a particular test is failing, always be sure you understand like how the test is being run, right? Like what's the input that's being fed in, how is it being run, and then how is it being tested, and then try to understand, okay, if that's how the test is being run, then why is it failing, right? It usually does not have to do with the inputs that are being put in. It's usually the way your code takes in the inputs, right? Because in almost all the workshops, we'll like create like the fake numbers for you, right? We just want you to focus on writing the function that processes those numbers. So if you find yourself like writing a lot of fake data to use, it probably means you're doing something redundant because the test probably already does that part for you. Okay. And then this is the last part, right? So this is, I guess, the VS Code thing that Josh asked about earlier. And really, like, fundamentally, what it comes down to is there other places you want to run your code? You want to run your code that allows you to kind of find other ways to monitor your code as it runs. The debugger is something that a lot of people use. I actually don't like using it as much for this class, just because I think it kind of opens up this whole realm of like things that could be helpful, but more often than not, probably will be more trouble than it's worth. I'll show you kind of how it works, though, just so you have a sense of what it is. So if I just go to any, I wonder if, nope, this does.
Have you opened your console this evening?
Yeah, I've tried to do it in REPL before, and it doesn't. I guess it doesn't work. Hopefully REPL works better. Okay, so what this does is, what I did is I open up my Chrome thing, and Chrome, you can just paste JavaScript and run, right? Because Chrome is just a JavaScript engine that runs JavaScript. What debugger does is wherever you drop debugger, what it will do is it will actually stop. Oh, wow, it's super small. Too big. Just right. Okay. So when you drop debugger, what it'll do is actually stop the code at that moment, and it'll give you a bunch of options, which are like, hey, let's run the next line of code, and then stop and ask you for permission before it goes to the next line of code. So it will literally run the code for you step by step by step by step. The only caveat is, you need to put in your own test inputs there, and you're also doing it in the Chrome console, which is very powerful, but it's kind of like a learning curve to getting familiar with it, to be comfortable with it. So with debugger, feel free to use it if you're comfortable with it already. If you're not, like running the code step by step and dropping console logs in places are, in my experience, sufficient for this class for you to kind of figure out, in most cases, where your code is going wrong. Okay, so debugger is an option, but I don't want to spend too much time on it because I feel like it's this rabbit hole that is more of a time sink for us at this point than useful. Okay, and then cool. All right, so that's pretty much it. The crux of this workshop will be on the loops. The debugging thing is something that's going to be a theme throughout the rest of your workshops for the rest of this week. Any questions on primarily, I guess, loops, break, continue, or return or console logs, for that matter? Yeah, right.
Sometimes when I try to use a return statement, it says illegal return statement.
You probably don't have it inside a function.
It gotta be after the curly braces or before.
within a set of curly braces, in between them. Yeah. Cool. All right. I will get Pearson out, and then we can get started.